Alright, today we're going to talk about ratios, and a ratio is simply just a comparison of two things. So here I have 3 white circles and 2 blue circles. So if I write my ratio of white to blue, I would have 3 whites to 2 blues. Now you can write this 3 ways. You can write it with the word 2 there. You can write it with the colon. Or you can write it as a fraction. If I wanted to do the number of blues to the total number, I would have 2 blues to 5 circles. Again, I can write that 3 ways, with the 2, with the colon, or as a fraction. So that's the 3 ways to write a ratio. Alright, so now I have some more ratios I can make. I have stars and arrows. So if I want the number of arrows to stars, I have 4 arrows to 3 stars. Again, I can write that 3 ways, with the 2, with the colon, or as a fraction. If I wanted the number of arrows to total, I have 4 arrows to 7 total shapes. Again, write that 3 different ways. And next we'll explore equivalent ratios. Alright, so let's look and see if some ratios are equivalent. So there's a few different ways you can do this. First, you can take these ratios. I have 48 and 16 to 32. And I could reduce them down to their simplest form. So 4/8, you can divide both those by 4. And 4 divided by 4 is 1. 8 divided by 2 is 2. 16 and 32, you can divide both those by 16. 16 divided by 16 is 1. 32 divided by 16 is 2. 1/2 equals 1/2. So those are equivalent ratios. Now, it's not always easiest to reduce your fractions. So the other way you can look at it is if I rewrite these, is what do I have to multiply 4 by to get 16? Well, 4 times 4 is 16. And then if this is a true statement, 8 times 4 equals 32. It is a true statement, so they're equivalent. There's one other way you can do this, and that is to cross multiply. And this will work, but sometimes your numbers get big. So here you have to do 8 times 16. 8 times 10 is 80. 8 times 6 is 48. 80 plus 48 is 128. So I multiplied those two. Now I need to do 4 times 32. 4 times 2 is 8. 4 times 3 is 12. So I get 128. So they are equivalent using that method as well. So there's 3 different methods there you can test for equivalency. So let's explore a couple more of those. Alright, so we have 2 8s and 7 28s, and we want to know if they're equivalent. Now looking at this, it's not easy to multiply 2 and get 7. You can do it, but for a lot of people that doesn't just come intuitively. So here we can either reduce them or we can cross multiply. So first let's reduce. 2 8s, you can divide both those by 2. And 2 divided by 2 is 1, and 8 divided by 2 is 4. And then 7 28, you can divide both those numbers by 7. 7 divided by 7 is 1. 28 divided by 7 is 4. So 1/4 equals 1/4. Those are equivalent ratios. The other way is to cross multiply. So if we were to do that, let me rewrite them. 2 8s and 7 28s. We're going to do 8 times 7 and 2 times 28. 8 times 7 is 56. And 2 times 28, well 2 times 25 is 50, and then 2 times 3 is 6. And 50 plus 6 is 56. So those are equivalent ratios. Let's do one more example. Alright, so now I have 2/3 and 10/16. So again, we can try and reduce this first. 2/3 can't be reduced, but 10/16 can. You can divide both those by 2. 10 divided by 2 is 5. 16 divided by 2 is 8. And 2/3 does not equal 5/8. Other way you can do it is to cross multiply. So we have 2/3 equaling 10/16. Let's check it. 3 times 10 is 30. And 2/16. 2 times 16 is 32. So these are not equal because 32 does not equal 30. So that is how you write ratios and see if they are equivalent or not.